Let's do simple ones. Okay, so on page 294, page 294, 29A, what is, if this is M equals 2, 1, 3, 1, what is the transpose of M? So see if you can write that down and then indicate when you're done so we can move on to the next problem. Okay. If two people done. Okay, so the transpose is this row becomes the first column, the second row becomes the second column. Note for square matrix, you can just think of it as sort of like flipping the diagonal elements don't change, you can just flip it up, right? But that doesn't quite work when you have a matrix like C in C. Okay. Now, here is, let's look at number 30. What's asking is the row vector 1, 0 in the row space of this matrix? Is vector in row space. So part of this is just trying to figure out what the words mean, right? So when you understand the words, what you'll be formulating it will end up being a linear system, right? So the first question is, what's the linear system? What's the basic equation you want to write down that expresses is this vector in this row space? So see if you can do that, and then either find an answer to that, or give up and raise your hand. When you say in row space, what you mean is in the span of the row vector space. Because row vector space is a span, so you're asking if this vector is in a span. So he goes baffled. Yeah. Okay, so what you're asking for here is if this is in the row space, you want to say, okay, well, that means that there's coefficients, there's numbers that allow you to write this vector as a linear combination of these two. So now I could then use my matrix operations to write this as 2AA plus 3BB, which equals 2A plus 3B, A plus B, right? Using my matrix, I'm multiplying in A and B here, then adding them together. And then I can see that my equations are to be equal. They have to be 2A plus 3B equals 1. And A plus B has to equal 0. That's the second equation. This has to equal 1. This has to equal 0. So if you can find A and B for which these are true, then you found that 1, 0 is in the space. So that means solving. If there's your linear system, then that you would write down 2, 3, 1, 1, 1, 0, right? And we could do a row operation minus 2, row 2 plus row 1 to give you 1, 1, 0. And that would give you 0 here, and -2 is 1 there. And that would leave that unchanged. And then I would do row 1, I would swap row 1 and row 2 to give me 1, 1, 0, 0, 1, 1. And then since you have A and B here, you can see that B equals 1. And then A plus B has to equal 0, so A equals -1. And we can check and see, does that work, right? Up here, because we're supposed to see that A is -1, B is 1. Well, let me see, this is 2, 1, 3, 1. And we want to know, is this going to produce 1, 0? So well, this is A is -1, plus B here is 1. Well, that's going to equal -2 -1 plus 3, 1, which equals 3 plus -2 is 1, and 1 plus -1 is 0. So it works. So therefore, 1, 0 is in the row space of uh, 2, 1, 3, 1, row space of 2, 1, 3, 1. Okay. So that shows sort of how to do. Then here, this is probably easier for you to do. Decide if the vector's in the column space, right? You do the same thing as write this. I think you can look at 31 and do that. Then here is decide if the vector's in the column space. Okay, here is a problem that it says find a basis for the row space of this matrix, right? An equivalent problem could be find a basis for the column space of this matrix. And what you do is you would just take this matrix and reduce it to echelon form, and that would be your basis, the rows. And if you had column space, well, you would transpose it, set it to echelon form, and then transpose back, and then the columns of the matrix would provide the basis for the column space. Okay, then finding the rank of each matrix, right? This would be, you reduce the matrix to echelon form, and the number of rows is the rank. The number of non-zero rows is the rank. Here's one, give a basis for the column space, give the matrices rank. And all these problems are very similar. I think like here's look at 43. Show that this set of column vectors, D1, D2, 3, where there are X, Y, and Z, such that this is true, is a subspace of R3. Find a basis. Well, that's you'd have to solve this linear system, and to rewrite to solve for anyway. So this is a complicated. But as you can see, it's sort of a linear system that we could think about how to handle. What I wanted to do for the last 7 minutes, maybe, was to look at the assignment 4, just to look at that. Now you do have assignment 3, the solutions to that, as well as the second version of assignment 3. But let's look at assignment 4. Oh, there it is. It's hiding behind. Okay. Yes. I think it's there. Okay, so determine whether the following set spans R2, right? Show that the following set is linearly independent. Then it goes on to 3 by 3 ones here. Determine whether the following set spans R3. show the following set is linearly independent or show it is not linearly independent. Find a basis for the following space. Find a basis for this vector space. Find a basis for this vector space. This one is column vectors, polynomials, 2x2 matrices. Is the following sequence of vectors a basis for R3? Verify that it is, or show why it is not a basis. Okay, then 9 and 10 is this stuff we just did with represent the vector V as a column vector with respect to each of the two bases. So you have basis 1 and basis 2, and you're given this is sort of the vector in the standard basis on the left. So you're given 3 minus 1 the standard basis, and you want to find it in these other bases. Okay? And this is the same problem as we know that 3 minus 1 is in the span of B1 and B2. What are the coefficients of that linear combination? And the same problem with polynomial vectors here. I've given you two bases, the standard basis and this funny basis, and you take this vector here and represent it as a column vector with respect to B1 and B2. So each one of these things is going to require solving a linear system. So basically, this is the stuff we just did at the end of today's lecture because we sort of passed over it in getting. So there's nothing about rank or dimension or matrices, but that'll come in the next assignment. But this is sort of 4, and this is more than halfway, right? So, and everyone is actually, most you guys are generally, seems like following clearly, getting your assignments done, and you all have reasonable scores that you can refurbish and get, I think, any score you want. Anyway, so I think you're well on the way to successfully getting through the whole course. And that goes even if you're just listening in and not here.